What if everything you see, every galaxy, every star, every particle, is part of a shape so vast, so strange, that your brain can barely comprehend it? What if the universe itself has a geometry, an edge, or maybe no edge at all? And here's the real question. If you could travel far enough in one direction, would you eventually come back to where you started? Welcome to one of the deepest mysteries in modern cosmology. What is the shape of the universe? Exploring the universe together, one mystery at a time. At first glance, the answer seems simple. Look around you. Space looks flat. Straight lines behave like straight lines. Parallel beams of light don't suddenly curve into each other. So, is the universe just flat? Well, not so fast. To understand the shape of the universe, we need to zoom out, far beyond Earth, far beyond the Milky Way, beyond even the observable universe. And that's where things start to get weird. In cosmology, scientists describe the universe using three possible geometries: flat, closed, and open. Let's start with the simplest one, a flat universe. In a flat universe, space follows the rules of Euclidean geometry. Triangles add up to 180 degrees. Parallel lines never meet. The universe extends infinitely in all directions, or at least it could. This is the kind of universe that feels intuitive. It's what most of us imagine when we think about space, but there are two other possibilities, and they are far more mind-bending. A closed universe curves back onto itself. Think of the surface of a sphere. If you travel in a straight line on a sphere, you don't fall off the edge. You eventually return to your starting point. Now imagine that in 3 dimensions. In a closed universe, space is finite, but it has no edge. You could travel forever and yet never find a boundary. No walls, no end. Just a cosmic loop. Then there's the open universe. This one curves in the opposite direction, like a saddle. In an open universe, space expands forever, and its geometry causes parallel lines to slowly drift apart. It's infinite, and gets more spread out over time. So which one are we living in? To answer that, scientists turn to one of the most powerful tools in modern astronomy, the cosmic microwave background radiation. This faint glow is the afterimage of the Big Bang. It's everywhere, in every direction. A snapshot of the universe when it was just 380,000 years old. By studying tiny fluctuations in this radiation, scientists can measure the geometry of space itself. And the result? After decades of observations from missions like WMAP and Planck, the universe appears to be almost perfectly flat, not curved like a sphere, not warped like a saddle, flat. But here's where things get even stranger. Flat doesn't necessarily mean infinite, and it definitely doesn't mean simple, because even a flat universe can have a complex topology. Imagine a video game world where going off one edge of the map makes you reappear on the opposite side. To the player inside the game, the world feels endless, but in reality, it's finite and wrapped around itself. Some scientists believe the universe could work the same way. A flat, but wrapped universe. This idea leads to exotic shapes like a 3D torus, essentially a higher dimensional donut. In such a universe, if you traveled far enough in one direction, you might eventually see the back of your own head. Light from your past, looping around the cosmos. But if that's true, why haven't we seen these repeating patterns in the sky? That's one of the biggest challenges. So far, we haven't found clear evidence of a wrapped universe. But the observable universe is limited. We can only see as far as light has had time to travel since the Big Bang, about 93 billion light-years across. Beyond that, the universe could continue forever, or fold back on itself in ways we can't yet detect. And then there's dark energy. This mysterious force is causing the expansion of the universe to accelerate. Not just expand, but expand faster and faster over time. Dark energy changes everything. It affects the fate of the universe, and potentially its shape as well. Even if the universe started with a certain curvature, billions of years of expansion could make it appear flatter than it really is. So what we measure today might not tell the whole story. We're seeing a snapshot, not the full picture. And there's another possibility, one that sounds like science fiction. What if the universe has more than 3 spatial dimensions? In theories like string theory, extra dimensions could be curled up at incredibly small scales, invisible to us, but influencing the structure of reality. If that's true, then the shape of the universe becomes far more complex than anything we can visualize. Not just a sphere or a saddle, but something beyond human intuition. Something higher dimensional. And yet, despite all this complexity, we keep coming back to the same question. Does the universe have an edge? Surprisingly, the answer might be no. Even in a finite universe, there may be no boundary, no wall you can touch, no point where space suddenly ends. Instead, space could be self-contained, like the surface of a sphere, but in higher dimensions. This idea challenges everything we think we know about inside and outside, because if the universe contains everything, then what would it even mean to go beyond it? There is no outside. The universe doesn't expand into anything. It simply expands, everywhere, all at once. So when we ask, what is the shape of the universe, we're really asking something deeper. What is the nature of reality itself? Is space infinite or just unbounded? Simple or impossibly complex? Flat or only appearing flat from our limited perspective? Right now, the best evidence suggests a flat universe with a margin of error so small it's almost unsettling. But almost is the key word. Because in science, almost isn't certainty. And until we can observe beyond the cosmic horizon, the true shape of the universe remains an open question, one that stretches the limits of physics, of mathematics, and of human imagination. Maybe one day, future civilizations will map the entire cosmos and finally uncover its true geometry. Or maybe, the universe is so vast, so complex, that its full shape can never be known. And perhaps that's the most humbling possibility of all, because it means that no matter how far we explore, there will always be mysteries beyond our reach, always more to discover, always more to question. The universe is not just stranger than we imagine, it may be stranger than we can imagine. So the next time you look up at the night sky, ask yourself, are you looking into an infinite expanse, or the inside of a cosmic shape, so vast, it hides its own boundaries? And if you could travel forever, would you ever truly get lost, or just come back home?